For centuries, we watched the birds and gained our original inspiration to fly. We envied their maneuverability, marveled at their control, and wondered what they could teach us. We dreamed of flying like the birds, sharing their sky, agile and quiet like an eagle. We learned to fly, but the machines we created were bound by current limits of science and understanding. What if we had a chance to revisit our dreams? What if we had the courage to rethink our science and take a bold step forward? We stand at the threshold of an exciting revolution in aviation technology. How we think, what we build, and where we go will have a major impact on our nation and our lives. Our nation relies on its air transportation system for commerce, national defense, and personal mobility. Our population continues to expand away from the cities into areas farther removed from major airport hubs. Our continued economic growth and prosperity are directly linked to the improved efficiency and safety of our air transportation system and the vehicles that fly in it. How can we change our system and aircraft to accommodate our increasing demands on them? Our continued dependence on large aircraft using huge, congested major airports has caused a dramatic increase in noise and pollution complaints from the public. How can we ease major hub congestion while improving access and increasing personal and business mobility? How can we diminish aircraft noise and pollution without sacrificing performance or safety? Those are just some of the challenges to aviation we are facing today. What new challenges will the future hold? The National Aeronautics and Space Administration is conducting aggressive research and development programs that meet today's challenges and will lead our country over the threshold into an exciting new era in aviation. As our first inspiration for flight came from watching nature, we find it essential to look again to see what else we can learn and apply. We are studying structures and aerodynamics at the molecular level. Our new understanding of nanotechnology and microtechnology has enabled us to create totally new materials and tailor them to specific needs. As a result, we are now able to build aircraft structures that can be 10 times stronger than steel, but weigh only half as much. We are developing adaptive materials that can change their shape when an electrical impulse is applied. When these materials are used in an aircraft wing, the wing can be made to change or morph its shape to improve the flow of air over the vehicle and reduce drag and ease propulsion requirements. Advances in sensor technologies have enabled us to begin development of an aircraft central nervous system. A network of thousands of tiny multifunction sensors distributed throughout an aircraft will collect data on changing flight conditions as well as monitor vehicle condition and even flight crew health. The sensors will continually feed information to an onboard computer system that will determine if any corrections or adjustments are needed. To effect the changes ordered by the computer, small devices distributed around the air vehicle will be used to control the aerodynamic flow, resulting in improved maneuverability, efficiency, and even noise control. The enhanced monitoring and control systems within this lighter, stronger airframe will encourage development of alternate fuel concepts and new propulsion system designs that will be quieter and more fuel efficient. The quieter, cleaner technologies now under development will also make airports desirable community assets. To assess our new aviation concepts and designs, we are developing the mathematical tools that will help us understand and simulate, predict, and establish the new rules that will define future vehicle systems and performance. Our advances in computer and information technology will give us unparalleled levels of safety and security in our skies. We are flight testing a cockpit vision system that will give pilots a clear view outside the plane at any altitude, position, or time in any weather. A new traffic monitoring system is being evaluated that will allow for safer, more efficient spacing of aircraft on approach to airports. And research is underway on an information and warning system that will virtually eliminate the possibility of runway collisions. All these programs and capabilities lead us to creating radically new air vehicles in a totally integrated control system that better serves our needs. The future demands that we have access to more of our country without sacrificing our security. The ability to live and work anywhere is becoming increasingly important. A design for a new air transportation system is evolving that will give people and business the mobility and access they need by utilizing thousands of existing smaller airports served by a new generation of aircraft operating under a virtually automatic control system. The technologies are in place to begin this approach. For almost a century, government and industry have turned to the innovators at NASA. From the first primitive wind tunnels to experimental aircraft to advanced computational modeling, the National Aeronautics and Space Administration is respected as the world's leader in aeronautical research. Because of our unique position and unequaled facilities, we are able to employ the finest scientists, engineers, technicians, and support staff in the world. They bring with them the talent, imagination, and commitment to continually push the envelope of aeronautical research and the courage to explore new frontiers. By evaluating each concept, each design, and each system, by inventing new ways to meet challenges and solve problems, and by applying the finest scientific minds in the world, the National Aeronautics and Space Administration is taking the role of innovator and integrator of America's bold aviation future, opening the door to possibilities never before imagined.